Hi everyone. Today we are going to discuss about the wavelength and the velocity of the sound wave and the relationship of wavelength and velocity of the sound wave. Before I start with the wavelength, let us just try to recollect our theory what we have studied. We have studied the sound wave is a longitudinal wave. That means we are getting sound wave is the in fashion of compression and rarefaction. So this is compression and this is rarefaction, where density is less. That means less number of particles are there. Now again here you will see compression and again you will see rarefaction over here. So this is compression and rarefaction. Like this you will see your wave, sound wave is traveling. So this is compression, this is rarefaction, again compression, again rarefaction, and it will go on like this. Now we will represent this in a graphical form. So in graphical form already we have discussed. So we will represent this like a wave like this. What is this? So if we have already studied in compression, pressure is maximum, pressure increases and density increases because more compact form of particles are there. So more particles are there. That's why density is more. And in rarefaction, density is less and pressure is less. So here, if this x-axis represents the normal density, then this is your compression, because here you will see from the normal density it is high up, that means density is more. So this is your compression. And what about this? This is your rarefaction. Here density is less, it is below the normal density line. Again you will see compression over there. Okay, so now we will discuss what is wavelength. As we have already discussed, one complete wave is one complete wave. This is one positive half cycle and one negative half cycle. So this is one complete wave, one compression and one rarefaction, that is one cycle. So what is wavelength? Before going to wavelength, we must know what this point is called. This is called crest and this minimum point, it is called trough. So the maximum point, this peak, the positive side, is called crest, and this minimum value, like this is a big hump. So the maximum point is called crest and this minimum point is called trough. That is like minimum value. This is minimum value. So it is like a valley. It is like a valley. It is like a big hump. So these peak points, these points are called crest and this is called trough. Then what is a wavelength? Now we will discuss what is a wavelength. A wavelength, name suggests, wavelength. That means a wavelength is a length of a complete wave. Wavelength. So wavelength, this is a length of a wave and it is denoted by the Greek letter lambda. Greek letter lambda, and it is measured in meter. And it is measured in meter. So wavelength is denoted by lambda and measured in meter. So what is wavelength? We have discussed this is crest, this is crest, this is trough, this is trough. So wavelength is the length of a complete wave. That means from here to here, you can say this is a complete wave. So this is your wavelength. Usually we say wavelength is the distance between from crest to crest or from trough to trough. This is also lambda, this is also lambda. So this can be a wavelength, this can be wavelength, and this can, it all are same. This can be wavelength. How it is? This is, see, if this is lambda, so this will be lambda by 2 and this will be lambda by 2. So half of this. So this is your, we are considering how it is same. This is like lambda. So lambda means, so this is lambda by 4, this is lambda by 4, this is lambda by 4, this is lambda by 4. So this is 1 lambda. Again, if you consider from crest to crest, like this distance. So again this is lambda by 4, this is lambda by 4, this is lambda by 4, and this is again lambda by 4. So this is all same. This is all same. So wavelength, what is lambda? It is the length of a wave from here to here. Length of a complete wave. We can measure like this, or we can measure from crest to crest or trough to trough. I think I am clear about wavelength. Now we'll discuss about the velocity of a wave. All you people already know what is velocity. In motion chapter, you have already studied what is velocity. What is velocity? Velocity is the distance covered by time taken. So let a wave travels a distance lambda. Let a wave travels a distance lambda in time t. Then what is the velocity of the wave? So velocity of the wave will be distance traveled. It is distance traveled by time taken. By time taken. So let a wave travels lambda, distance lambda in time t. So what is the velocity of the wave? It will be lambda by t simply. What is this lambda by t? We can write lambda by t as lambda into 1 by t. And in last video we have discussed what is this 1 by t. This is your frequency f. So it is lambda into f. So that means lambda v is equal to I'll make it clear, less space. Let me draw a bit so that I can write this equation more clearly. So velocity v, what we got? Velocity v is equal to lambda by t. That is, we can write lambda into 1 by t. So from here we can write v is equal to lambda into f. So this is, we can say, the wave equation. Velocity is equal to lambda wavelength into frequency. So velocity is equal to wavelength into frequency. This is a very, very important equation. I think it is simple, it is easy. Velocity is equal to wavelength into frequency. So what is the velocity of a wave? It is the distance covered by the wave per unit time. So velocity is distance covered by the wave per unit time. Now we'll discuss speed of the sound depends on what? On which factors speed of the sound depends? Speed of the sound depends on which factor? Dependent on which factor? First, it depends on the nature of the medium. Speed of sound dependent on nature of medium. That means if you change the medium, the speed will change. That means if you change the medium, suppose sound is traveling in air, the speed will be different, and same sound when it will travel in water, it will be different. So speed at room temperature, the speed in air is equal to 344 meter per second. It is in the case of air. And the speed of the sound in water will be 1500 meter per second. This is in water. I think in first video we have discussed sound travels faster in solids. I have asked one question, so I have also explained why it travels faster in solids if we compare to gas and liquids. So here also you can get that the same feeling. See, in air the speed of the sound is less in comparison to water. That means speed of the sound is maximum in solids. If you take it in iron rod, in glass, it will be more. So speed of the sound is maximum in solid, then less in liquid comparatively. This is the comparison. And least in gas. So fastest in solid, faster in liquid, and least in gas. So this is the first factor which affects the speed of the sound. So at room temperature, this is the dependency of the speed of the sound on nature of the medium. Then second, it depends on the temperature. Second point, speed of the sound depends on temperature. How it is? Speed of the sound in air at 0 degrees Celsius. Speed of the sound in air at 0 degrees Celsius is 332 meter per second. And speed of the sound at 20 degrees centigrade, 20 degrees Celsius will be how much? It is 344 meter per second. So what? You are now getting the feeling from this data? That means if temperature increases, speed also increases. Speed also increases. I think I am clear on this. Speed of the sound dependent on temperature. As temperature increases, speed also increases. Next. Third, speed of the sound dependent on humidity of air. Humidity of air. Humidity means more humid weather. That means droplets are there. In rainy season it is more humid. Okay. So if humidity increases, then speed also increases because water particles are there and we have already studied in liquid it moves faster, speed of the sound is faster. So if humidity increases, then speed also increases. What does it mean? Sound travels slower in dry air than your humid air. That means sound travels faster. It travels faster in humid air than your dry air, humid air, and slower in dry air, and slower in dry air. So common example, we know the sound travels faster in rainy day. Sound travels faster in rainy day because of this reason, because of humidity. So you can get in exam the reasoning question. Why sound travels faster in rainy day? So you can write, because as humidity increases, speed also increases. That's why sound travels faster in rainy day. I hope I am clear on speed also. So for today I think I am going to discuss only this much, and tomorrow I will upload again the video of characteristics of sound. It will continue. So tomorrow I am going to discuss about the loudness and pitch. So after loudness and pitch and quality of timbre, these three characteristics are remaining. So by tomorrow I will try to finish the characteristics of sound. Hope you have understood clearly what is this wavelength and what is the velocity and what is the relationship of velocity and wavelength. Thank you for watching me.